Hello, everyone. Thank you very much for having me. Firstly, thank you to ITAPA for inviting me. Thank you for having me. It's an honor. Beautiful Bratislava. Went out last night and visited all the Christmas markets, and it was beautiful. And so, yeah, thank you very much. My name's Phil Winder. I'm the CEO of Winder AI, and we are an AI agency that helps companies build out their AI applications and platforms. I'm here today to talk a little bit more about the practical application of AI, and specifically talking more about the use of data, specific use cases and what makes a good use case, and then finally a little bit about regulation as well. A bit about me: I'm the author of O'Reilly's Reinforcement Learning. I'm an AI practitioner, data scientist. I've been running Winder AI since 2013, so we're one of the oldest consultancies in the world. We've been doing AI for a long time, so we've seen lots of use cases and worked for some of the world's largest companies. So just before I get going, I'd just like to pop up a surprising stat behind me. So there's lots of statistics out there that suggest that AI projects don't work. IBM themselves say 80%, more than 87% of projects fail. Rand Corporation, Harvard Business School. There's lots of statistics out there that will tell you that AI doesn't work. I'm here, and this presentation is attempting to prove to you that these statistics are not true. And the main reason for that is that if 8 or 9 out of 10 projects fail, then I wouldn't be in business. And I've been doing this for 12, 13 years now, and I'm still in business, so these are not true. I'm going to talk a little bit about how you can help prevent your projects from failing, because there's sort of underlying reasons why it does happen, but it's certainly not as high as 80%. And that's borne out in the data. This is a plot. I might get out of the way a little bit. This is a plot from McKinsey that's demonstrating the percentage of businesses that are using AI. And so it doesn't quite go back as far as 2013, unfortunately, but in my experience, around 2016, that's where it kind of came from the 0% line and started to ramp up. So 2017, 18, and 19 saw a big increase in the use of AI in businesses. Plateaued for a little bit, for a few years, and then finally in 2022, 2023, basically when ChatGPT came out, that sort of started another wave of businesses adopting AI. And now we're seeing more than 70% of businesses around the world are saying that they are using AI. So if 70% of businesses are using AI, then definitely 90% of projects don't fail. Fact. Okay, so split into 3 parts. I want to talk a bit more about the underlying data, why data is still so important in AI. I'll touch upon some use cases that are quite interesting and fun, and then finally talk a bit more about regulation. So on the data side, I think I'm actually going to switch it around a little bit, because I want to talk about data cleanliness first. So I think we saw a little bit in Anton's presentation in the demo there. There was a couple of points, actually. We'll touch upon the data management in a minute. But a large part of the problem in any data science or AI project is finding example data to use to train your models that is both representative and clean. And so what I mean by that is that if you try and train a model on data, that data has to be realistic. It has to be representative of real life. It has to be clean enough so that it doesn't break the training process, and it doesn't break the model when it goes into production. Specifically, I mean things like bad data in the sense of like missing data, corrupt data, invalid data. We saw in that demo that there were a few things going to like an invalid bucket. That's a good example of that. In terms of the sort of the quality-related metrics that you need, you really want to be focusing on trying to find data that's representative, because the predictive power of a model is only possible if you have data that demonstrates all previous possibilities. If you try and predict something based upon data it hasn't seen, then it's very likely that it'll go wrong. So that's robustness, model robustness. All of this is kind of wrapped up within data management in general. Again, in Anton's demo, we saw that basically 90% of the demo was moving data from one place to another. So handling and managing and pushing and moving all of that data to the right place at the right time in the right way is 80% of the problem. And so it's worth investing time and effort into the management of your data. And when it comes to compliance later on, this also becomes a crucial aspect. You need to be able to tell the regulators where your data is and how it's used. If you can't do that because it's buried in some data scientist code somewhere, then you're going to have problems. And finally, I'm going to spend a little bit more time talking about transparency. And data transparency, this is the idea of publishing your data, showing your data to the public. This is more relevant to the public sector than it is the private sector, to be honest. But still, it's very relevant for everybody because transparency inspires trust. And trust in AI, trust in governments around the world, trust in people generally is only possible with transparent data. And to highlight this, I want to just show a little bit of an example that I mocked up. I wanted to actually show this live. This is actually a web page. This is just a picture of a web page, but you can browse to it if you go to the link at the top there. I'm from the UK, and this is a map of England and Wales. Where I'm from, I come from, does this laser pointer work? Oh, it does, but you can't really see it. I come from Yorkshire, which is way up there, all the way in the north, far, far away from London. And historically, there's been a very, very, well, culturally, there's a very big difference between the north and the south. We call it north-south divide. And one of the ways that is expressed commonly is in wealth, is in money, how much people earn. So this is a plot of the average earnings for people in the UK, for people in England and Wales, sorry. And the interesting thing about this data is that it's done to a really small geographical level. It goes down to really small geographical regions. And so you can kind of zoom into some of the cities and see some really fine-grained metrics there. Yeah, I wanted to sort of demonstrate this as a use of transparent and open data. This data comes from the ONS, which is one of the government bodies that is responsible for generating government and publicizing government data. And I thought about this for a moment, and actually, I don't think it's quite the right metric, because you can kind of see from the sizes of some of these regions that the regions are basically based upon the number of people live there. And in the north especially, there's far fewer people that live there, and therefore the housing costs are actually much cheaper. It's much cheaper to live in the north than it is the south. So how could I try and take this public data and figure out something new? So this next plot here is the same data, but I've subtracted housing costs. So this is now basically the average income in a family when you've removed the cost that it costs to live there. And we can see that the map has completely changed. If I kind of flick between backwards and forwards, this north-south divide that was previously there in the other data is now kind of changed. There's a big red band that heads up sort of through Birmingham and up to Manchester up there. There's even a little bit in Yorkshire in the top there. But I think the main thing that comes out of this is actually the disparity between like the central band and Wales on this side and the East Coast on this side. Huge disparity there in terms of the average income of those families. And so if you were a policymaker, if you were in government, you might want to try and target programs to be able to maybe upskill that work, however they do it, but basically invest in those regions to help bring them up to the rest of the country. And this is all just, again, through publicly available data. And I was only able to do that because it was transparent, it was easy to access, and it empowers, citizen data scientists like me. There are more commercial operations that use data like this to do more interesting things. This is another downstream example of that data. Transparency International is a charity that aims to quantify the level of corruption in various countries in the world. And so this is one of their graphics that they show. I was interested in the UK's perception of corruption, and specifically how that relates to politics as well. I'll try and leave politics out of it as much as I can. This is the raw data that I scraped from the Transparency International's website, and it kind of doesn't really show that much interest. So I think the first thing is we've got error bars on here. So error bars are a measure of how much error there is in the data. So that's always great to see in a data set, because we can see, like, if you look at some of these, the orange and green lines in the middle there, the error bars are actually extending further than those two data points, which means that they're effectively statistically the same value. You can't say that there's a difference there. But there's certainly a difference in the blue line at the top. And you can see it kind of dips down there. So rather than viewing it like that, it's actually more interesting to view it in terms of rankings. So these are like raw transparency, raw corruption index values. These are rankings in that data. So number 1 would be least corrupt, rank 100 would be the most corrupt. And we can see that we've got the UK line in blue, and there's a couple of interesting points that happened during this period. We've got the Brexit referendum at the top there, and I thought that that might have an effect, but in fact it kind of seems to have caused a bit of a bump because, you know, we did a referendum, half of the population didn't like it, and we did it anyway, so that kind of demonstrates no corruption. Whereas we've got the COVID-19 pandemic, and just after that, the UK tanked compared to Ireland here. This Ireland is in the green line. There's been lots of stories in the news recently about government contracts going to the friends of government. So that's potentially one of the reasons why. Another one is the orange line. We've got the United States. They're kind of doing okay, similar levels to Ireland and the UK until Trump takes office in 2016 and then again tanks. I'll leave it there because I don't want to get too much into politics. Okay, so actually, let's just finish off this section. So the whole point of this section is I wanted to demonstrate the use of transparent data and why it's useful. It can not only inform policy decisions, but it also enables downstream businesses and charities to generate their own derivative data. And then I've used that derivative data again because they've made that data transparent. So really powerful, really useful, can actually enact change. Okay. Let's talk a bit more about use cases now. So in my business, we're in the business of building AI applications. I've got a couple here that I want to talk about. Firstly, just a couple of examples from us, and then a couple of examples that I'd like to show a bit later. So the example on the left here is a product called Stable Audio. So we worked for a company called Stability AI, who are based in the UK, and they are the developers. They own the models, Stable Diffusion, Stable Audio, the various stable kind of brand of models. And we help them create Stable Audio, and this is a generative AI that generates music. So basically, go to stableaudio.com. I'll give you, a few free examples. Type in some text, and it'll generate some music for you. So much like many of the examples we've already seen, it's another very creative demonstration of how Gen AI can be used. In terms of efficiency gains there, you can imagine a traditional, if you were an advertising executive and you needed to commission some music for your advert, that would typically take you months. Now using a tool like this, you can mock it up in a very short amount of time, minutes. So we're talking about 1,000 times kind of levels of improvement. On the right-hand side here, this is a project we did for Temple University in the US, and their work involves legal research. So they go around the US and collect all of the legal text for each individual state, for the government, and each individual county. And they do research to find out really what the law is in the US, because the US is still quite fragmented legally. And depending on where you are in the US, you have different laws, and they're sometimes quite severe. Everything from abortion laws to drug use laws to eviction laws. They're all different depending on where you live. So we help them build an application that, again, is powered by language models to first find the right data. Secondly, segment that data so that they're only looking at the bits of text that are relevant to the question they're asking. And thirdly, actually answering the questions that they're interested in based upon that text. Again, previously they used to have to use a lawyer throughout this process. It took them a month maybe to sort of research one topic, and now again in a matter of minutes probably this is now possible. So 1,000 times speed up again, massive efficiency gains. A couple more funny ones and serious ones here. The one on the left here is a great example from an art project that went into a church in Lucerne. And they basically took all of the Bible and then trained a language model on it and called it an AI Jesus. So if you're in Switzerland, if you're in Lucerne, you can go to the church and talk to AI Jesus. So I thought that was quite fun. Example on the right is a little bit more serious. The Ocean Cleanup are a charity that go around the world's oceans cleaning up plastic. They have two main problems. Firstly, they want to actually quantify all of the plastic that they find so that they can say 80% of our plastic are shopping bags or whatever. So they have models, vision models in this case, to be able to classify what type of plastic it was. But also we were a tiny bit involved in a project where these massive trawler nets that are miles wide, they quite easily trap whales and turtles and big mammals and things like that. And so they were very interested in talking to us to talk about a animal detection model to allow them to detect them and then free them from the nets when they get caught. So a couple of takeaways, because I'm rapidly running out of time. So the first thing is focus on specific needs, all right? It's the use case that matters. One of the main reasons why projects fail is because the projects tackle the wrong problem. Businesses don't really want the problem that you're tackling. You're just doing it for fun or because it's easy or because you've seen an example on the internet. You actually need to speak to the business or speak to the person that's in charge of the project in order to get the problem right in the first place. So tackle the right problem. Second tip is to build for scalability or enablement. The most successful AI projects all tackle problems that have a high scale requirement. So I mean, in terms of imagine you're a business and you need to make 1,000 decisions a day to maybe accept an application for a loan or something like that. Thousands and thousands of decisions a day. If you had to hire people to do that, it would take a lot of people, and therefore that's a perfect example for AI. If you've got a large, scalable problem that can enable some other product. Data is still really important, even in the world of LLMs and ChatGPT and stuff. If you are using bad data, bad examples, bad inputs, you'll get bad outputs, garbage in, garbage out. Try and build your AI solutions to collaborate with people rather than replace them. We had one really good example, actually, for a very big but very traditional manufacturing organization. They manufacture paper, and they have giant industrial plants full of chemicals that bleach the paper and extract the pulp and change the pH of the paper, and so on and so forth. And we actually built a reinforcement learning-based algorithm to optimally control the process to produce paper for less cost, faster, whatever. But actually, in the end, we had to change the problem definition to, rather than just being a control problem, to make it into a recommendations problem, because we wanted to work with the engineers rather than actually replace them. And so rather than saying set the chemical to this amount, it says, we suggest that you set it within this range, and it leads to easier adoption and easier use. And then ethics. It's a very broad topic, but I talked a lot about transparency here. And there's a couple of things in the legislation coming up that that force you to be more transparent than you currently are. Okay, moving swiftly on to regulation now. I'm going to skip over this a little bit because it's already been mentioned a little bit today. We've all heard of GDPR, which is the Privacy Data Protection Law. But there's a new law called the EU AI Act that is already in force now. We've written about it a lot on our website, so maybe check out our blog if you want to learn more. The EU AI Act is really interesting because it's the first piece of legislation that directly affects data scientists and AI engineers, and actually software engineering in general, because there's very little regulation for the sort of generic use of software. And so this is a really interesting to see how this plays out. And the main reason for it is that the legislation is written in terms of applications. So specific applications have been prohibited, as in if you use them, then potentially you can get fined a huge amount. I can't remember the fines, but they were massive. We're talking, percent of global revenue, kind of massive. So yeah, there's quite a few applications especially in the sort of HR space. Recruitment space, which are now completely prohibited. There's also a lot of high-risk applications that have a large, like an additional burden that is now required in terms of testing and compliance and basically proving to the regulators that you're doing it well. And even low-risk applications, there's still a little bit of a burden. You still need to be transparent to your users that, for example, the output has been generated by an AI. So there's burdens on everybody. So yeah, keep up to date with that. I might skip over that to save time. But I think there's another bit that's kind of missing as well. So GDPR covers personal privacy really well, the personal privacy of your data. However, it doesn't cover the commercial privacy of proprietary business data. And so I think that this is going to be the next battleground, commercially at least. It's the idea of data sovereignty. It's the ownership of your data within your company. And it's interesting because there are various laws around the world, IP law, copyright law, but surprisingly, you can't trademark or patent data. You can only patent processes that use that data or generate that data. You can't patent the data itself. Okay, so the only thing that really covers raw data is copyright law, like old school copyright law. And that really doesn't really work in this day and age when so much content is put into the public. There's many cases going through the courts at the moment that are testing whether the use of public data to train models is fair use. They're arguing it is, but the data owners are arguing that it's not. We don't know what the result of that will be. So we've got the privacy laws on one side. All of them have national security exceptions as well. I'm really interested in this. This is a slight aside and a little bit paranoid, but I'm still really interested in it. All of these laws have national security exceptions in it, and we know that a lot of companies wiretap data. One of the reasons why the UK is so interested in this space is because this is a map of the subsea trunk fiber optic cables that go around the world. There's not many of them, okay? There's only this many. From Europe, the vast majority of them are coming from the UK here. Okay, there's none from France, none from Spain, none from Germany. There's a couple from Denmark, but not many. So probably 90% of Europe's data going to the US goes through these trunk cables. And this is why GCHQ in particular, which is like the UK's NSA, is basically scraping all of the data that's going through there. And they were even found to be like in violation of the European Convention on Human Rights. But like I said, there's national security exceptions to all of these laws, and so they're allowed to do it. But that's a fascinating read if you're interested in law here. And there's many more laws as well. So this is all spawning a new idea of private AI. Private LLMs, private ChatGPT, private models, basically with the aim of securing your data, not having to transmit your proprietary, valuable private data to a third party, especially in a different country. And there's a really simple way of achieving that. Firstly, speak to someone like Winder AI to build private AI services. Anton said the same about Red Hat. It's not that difficult to do. There's large engineering challenges involved, but it is possible. Check out Helix ML. That's one of our products. We're building a private LLM stack so you can run it on your own hardware. Basically, think of it as like ChatGPT, but in your own data center or in your own private cloud. Robust data governance and tracking. Yeah, you can only be sure that your data hasn't leaked to third parties if you're sure about where the data is and how it's being used. And the regulation, ironically, is actually here to help, because all of the regulation that is there to protect public data kind of works if you treat private proprietary company data in the same way. So many of the controls needed to do this, you might already have in place. So conclusions. So AI is a game changer. It's touching every part of the business. It's touching all industries. It's really hard to do sales, actually, because it's like, well, what sectors do you work in? And we're like, all of them, you know? So it's really quite hard. But you do need to think still about your data practices, your data cleanliness, your data management, and specifically be very picky about the use case. Make sure you nail the use case before you start anything. Compliance is obviously important. So the question isn't really whether you will adopt AI, because people already are. Businesses already are. 70% of businesses are already using AI. So the real question is how you will lead the integration of AI and what direction you will take. Okay, so I'm conscious I've run out of time, but I just want to shout out to my company, Winder AI. We help companies build out their AI applications and platforms. If you're interested in talking about some of those use cases and talking them through, please feel free to reach out to me. You've just got rid of my information. Phil at Winder AI. Phil at Winder AI. I'd love to speak to you. Thank you very much.
Phil Winder, everybody. We have a couple of questions. Please, thank you very much for the presentation. Don't go anywhere.
I won't.
We have a couple of questions coming through Slido.
Yep.
We have a rather cynical one. Someone was asking, with all these tools, do we even need people?
Yeah, of course, because the answer's in the question. These are just tools. Like, we have tools for everything. We have tools for eating. We have tools for woodworking. But we still need the people to be able to use those tools in an effective way to be able to solve problems. So, yes, is the answer to that.
You said you've been working with AI for more than a decade. What has been the biggest change in recent few years since ChatGPT has taken off and similar tools?
Yeah, so the biggest change for me over that time is the change in the terminology and the change in the wording used to describe what we're doing. Like, back when I started, it was like signal processing, and then it was data mining, and then it was machine learning, and now it's AI. And I've kind of, well, yeah, anyway. So that's been a huge change, but a lot of the techniques are still the same. The really big change that's happened since ChatGPT is the change of interface. So in software, we talk about interfaces as the way to communicate with, the way to communicate with different systems. And traditionally, AI models are very, very technical ways of communicating with them. It's like data, statistics, APIs. ChatGPT provides you with a natural language interface. You can literally just talk to it. So anybody now can interface with this technology, whereas previously you had to have a PhD in statistics or whatever. So that's the biggest difference.
Okay, so there's the technology change. What about the change in terms of how much people use it, talk about it, and also how businesses view it?
Yeah. So one of the biggest challenges that we're facing at the moment is that businesses are fully aware that they need to do AI. They need to use AI, but it's really hard to kind of bring them back to the problem definition of the problem that they're trying to solve. And that's actually the biggest challenge that we have at the moment, because it's almost like a bit of a knee-jerk reaction to the popularity of AI. It's just people want to use it for using's sake, but that's when project failure happens, because you don't get the problem right, you don't get the use case right, and then ultimately the project never really gets used. So yeah, so yes, we are speaking to lots of companies. The maturity of those companies has changed a lot as well. So previously we used to work for, before like 21, 22, we used to work for highly technical companies. You know, the Googles, the Microsofts, the big oil and gas enterprises, people like that with huge engineering organizations. Now I'm speaking to like health and safety people and marketing people and doctors and things like that, but the people that are not involved in technology at all. So actually, there's quite a big communication barrier between somebody who works in the technology and somebody who works in like a more traditional sector. So lots of changes.
This is an interesting one. What tools, programming languages do you use for developing your AI models?
So again, I go back to this idea of it being a tool. So you pick the right tool to do the job that you're trying to do. Typically, in a commercial setting, the best tool is the one that will make you achieve the job fastest, because your time, yeah, and actually one of the most people worry about the cost of AI, the cost of training, the cost of things. The most expensive thing usually is the people time, is the developer time, it's the time it takes for developers to do their job. So the best tool that you can pick to solve your problem, that's what you should choose. I mean, typically, you know, Python is the language of data science. PyTorch is my favorite sort of underlying deep learning framework. There's a massive variety of other frameworks that allow you to onboard quite quickly to a specific task, but they're usually quite task specific. So find out what your use case is, find out the tasks that you're trying to accomplish, then do some research to find out what are the best tools for that job.
Phil, thank you. Phil Winder, everybody.
Thank you.